carbon dioxide and chlorine gas. Let's start off with a test for oxygen gas. As you can see here, I've got a gas jar and I've got a burning splint. Well, the test is if that I put a glowing splint into oxygen gas, it should reignite it. So let's have a look at that again. So I've got a glowing splint, the flame's out, and when I put it into the oxygen, it should reignite. So to summarise, the test for oxygen is light a splint, then blow it out and then stick it into the oxygen. If the glowing splint then reignites, that is the positive test to say that oxygen gas is present. Next is the test for hydrogen gas. Now in this experiment to produce hydrogen gas, I've got some magnesium and I'm going to add some hydrochloric acid. So that fizzing that you see now, that is hydrogen gas being produced. So the test for hydrogen gas is when you light the actual gas, it should make a popping sound, more of a squeaky pop sound. Let's listen. There we go. Okay, so the test for hydrogen, as we just said as a summary, we light a splint, we place the burning splint into the hydrogen gas, and the positive test would be that the hydrogen burns with a distinctive squeaky pop. Next we've got our test for carbon dioxide using lime water. So if we look here, we can see lime water is colourless. Now to produce carbon dioxide, I've got some hydrochloric acid, and then I'm going to add some marble chips, which is calcium chloride. As the calcium chloride reacts with the hydrochloric acid, we should see some fizzing, which produces carbon dioxide gas. So there's my carbon dioxide gas hopefully being produced. I've got my little delivery tube here, and I bubble the carbon dioxide gas through the colourless lime water, and if we look carefully we should see that the lime water goes from being colourless to being milky, or cloudy we could say. It's a precipitate that forms inside which makes it go cloudy or milky. So just to compare, here we have lime water, which is colourless. If we bubble carbon dioxide through, it forms a cloudy precipitate. So to summarise, we pour lime water into a test tube or beaker and we bubble the gas into the lime water. And the positive test for carbon dioxide is it will turn the lime water, which is colourless, into milky.
Is how can I prove that a gas is ammonia? So the way I'm going to make my ammonia today is I'm going to take a sample of ammonia solution. Take a sample of ammonia solution, and what I'm going to do with that is I'm going to warm it up very slightly, which will encourage the ammonia to evaporate and therefore us be able to test for it. So in my solution here, you see my solution here, top of it, you can see I'm just warming it up very, very gently. And the way we test for ammonia is we use red litmus paper. So red litmus paper is great, but actually to make it work for this test, you need to make it damp. So I'm going to use a little bit of water. So damp red litmus paper in the presence of ammonia will turn from red to blue. So hopefully what you can see is that the bottom of that litmus paper is definitely turning a blue colour, indicating the presence of ammonia.
Cloudy colour. Here we now have the test for chlorine gas, and we're going to do some electrolysis. So I have some sodium chloride, which is just salty water, and I put it into this little piece of apparatus over here, which is going to pull the chlorines to one of the electrodes. So as I turn on my power pack, what we should see is some bubbling, and that is chlorine gas being produced. And normally you do this in a fume cupboard. So we've got chlorine gas being produced. What is the test to prove that it is chlorine gas? Well, we use a piece of litmus paper, and in this example here I've got some blue litmus paper, which first of all we dampen, and then we hold it next to the chlorine gas. Gradually what happens is it will go slightly red in colour, and then it should start to bleach. In other words, it should start to go white. And if you look just at the end there, you can see it is bleaching it a white colour. So we can see the bleached white section and the slight red section over there compared to normal litmus paper. So to summarise, the test for chlorine gas is you dampen litmus paper and you place it into the gas. A positive test, if you're using blue litmus paper, it should go red and then bleach, in other words go white.
In this video, we're going to test for sulfur dioxide gas. We're going to test for sulfur dioxide using acidified potassium manganate solution. To produce sulfur dioxide, we're going to react sodium sulfide with some dilute nitric acid. Connect a conical flask to some acidified potassium manganate solution using a delivery tube. Now we'll add some sodium sulfide to the conical flask. Then we can add some acid into the solution. Close the conical flask with a stopper. The bubbles are produced due to sulfur dioxide gas. Sodium sulfide reacts with the acid to produce sulfur dioxide gas. The sulfur dioxide gas produced decolorizes the purple acidified potassium manganate solution.